All right, so in this problem here, we're talking about identifying functions as even or odd. There's two ways in which we can identify whether or not a function is even or odd, either by its graph or by its actual equation. So first off, let's talk about graphs. Even functions will tend to have graphs which are symmetrical across the y-axis. So for example, the y equals x squared function, this is even, all right? It's even, right? Because you can see it's the same on the left side as it is on the right side. Functions which are odd tend to look like, for example, okay, I'm going to write this is y equals x squared. They tend to look like the y equals x to the third function, which goes like this. Now, in reality, what's going on here is that the right-hand side is the same as the left-hand side if you look at it as a reflection over the y and the x-axis. The other way you can think about it, and let me try to use the lasso right here. The other way you can think about it is that if I rotate this 180 degrees, right, it looks the same upside down as it did right side up. So these are like kind of the physical, graphical ways of identifying even versus this one is odd. Okay. Now in this function here, you can see that it looks to be not even, right? The left-hand side goes down, whereas the right-hand side goes up. When something like this is happening, it's pretty clear that it's probably going to be odd if it is anything. Keep in mind, guys, that it's possible for a function to be neither, right? The function doesn't have to be even or odd. For example, this function right here that I'm drawing, this guy is neither even or odd, right? Because it's not symmetrical and it's not the same thing upside down. But this guy right here, you can see if you think about it, it's going up, it's going down the exact same pattern, so this one is odd. Now, let's look at functions. Functions have a much more kind of technical definition. An even function should have the property where if I plug a negative value into the function, right? See, if I have f of negative x, it is equivalent to if I plug the same value in, but positive, f of x. So for example, let's look at our x squared function. F of negative x would be negative x squared. And that is equivalent to x squared because when I square a negative, it becomes a positive. Odd functions have the following property. When I plug a negative inside of it, it is equivalent to the same function to the function as is with a negative outside. So you see how the negative goes from the inside to the outside. So for example, the x cubed function. If I plug negative x into x cubed, a negative value to a odd power actually stays negative. Oh, and look, this is x cubed, which is f of x, with a negative on the outside. So it is odd. So let's try this guy out. When I plug a negative in to g of x, what do I get? I get g of negative x equals negative x to the fourth minus 2 times negative x squared. Well, negative x to the power of the fourth, 4 is even, so this would become a positive value. Minus 2 times negative x squared, that becomes x squared. And what do you know? This is g of x. So if g of negative x is equal to g of x, this must be an even function.